So good morning, everyone, and welcome to this class. This is lecture number 2 in the topic on center of mass. And in this particular topic, we will be dealing with the concept of collision. Well, in the previous class, we had seen the concept of center of mass. Do we remember that concept, everyone? We had found out the location of the center of mass of various bodies. Do we remember this? We had found out how to locate the center of mass in cases. Here we had solved one problem. So before going further, I will just give you one more problem on this because I know that the center of mass, one problem can definitely come. So I'll give you one more problem on the type that we had discussed in the previous class so that if this question comes, you should be able to find out the center of the mass. So I'll give you this problem, and I hope that you can solve this problem. You remember how to solve the problem? Yes or no? Of center of mass. Great. So I'll give you this problem, and the diagram is not there with this problem, but I will draw. I will give you the diagram as well, and I will hope that you can give me the answer for this problem. Give me the answer for this problem. And here is the problem. So first you can solve this problem. Four particles of masses 1 kg, 2 kg, 3 kg and 4 kg are placed at the four vertices A, B, C and D of a square of side 1 meter. You have to find the location of the center of mass, and here this object D is placed at the origin. So that is why I wanted to show you the diagram. I hope you see the diagram now, right? Yes or no? Everyone sees it? So now I'll give you 2 minutes to try and solve this question. And I hope that you can get the answer for this question. It's a very simple question. You have 2 minutes to solve it. So can anyone help me? How are you going to solve this? Can anyone help me with this? Can anyone help me how to solve this? Okay, no one wants to help me. Not a problem. You have to find the x position of the center of mass. I will apply the formula of so it is summation of mixi, means we add mixi and we divide it by the total sum of all this. Let me call this as 1. Let me call this as body 2. Let me call this as body 3. And let me call this as body 4. The mass of this body is 1 kg. The mass of this body is 2 kg. The mass of this body is 3 kg. Okay, so I should name them accordingly so it becomes easier for me to do this. So let me call this body as 1 kg, body 1, 2 kg, body 2, 3 kg, body 3, and 4 kg, body 4. So it will be m1 into x1. The x coordinate of this body is 0. So it is 0 plus m2 is 2 kg. X coordinate is 1. 2 into 1. m3 is 3 kg. X coordinate is 1. 3 into 1 plus m4 is 4 kg. The x coordinate is 0. So 0 divided by 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. So I have 5 by 10 as the x coordinate, and that is equal to half. So that is the x coordinate of the center of mass. It is half. How do I find the y coordinate of the center of mass? I will have to repeat the same process. I have to multiply the mass with the y coordinate and then divide it by the total mass. How I am going to do this?
1 plus 2
First mass is 1. 1 multiplied by 1 plus the second mass is 2. 2 multiplied by 1 plus
0
The third mass is 3 kg, but the x coordinate is y coordinate is 0. Fourth mass is 4 kg, but the y coordinate is 0 divided by 10. So I get this as 3
3
by
by
10.
10.
So this is the answer that we are looking for, beta. The x coordinate of the center of mass is half, and the y coordinate of the center of mass is 3 by 10. So that was the answer that we are looking at. I hope you got the answer for this one. Well done. Congratulations. Now let us move on to the next heading. And the next heading is collision or impact. So we'll write the next heading, collision or impact. Collision or impact. Anyone knows collision or impact? Collision or impact. Collision or impact. Now, what do you mean by this collision or impact? Now, collision or impact is a event where two bodies come in contact for a very short time and large forces act between them. Can you give an example of a collision? A bat hitting a ball is also is a collision. You are hitting something with a hammer is a collision. So what happens? Sorry, what happens in a collision? What happens in a collision? Very large forces or a very strong force acts on the body for a very short time, and because of this, the energy and the momentum of the particles change. This strong force that acts for a very short time is known as impulsive force. So you must understand that during collision, impulsive forces act on a body. These are large forces acting for a very small time. So we can say collision is an event where large forces act for a very small time. That event is known as a collision. We understand this, yes or no? Event of a ball hitting a bat, event of a shuttlecock hitting a racket, event of a hammer hitting a nail. Large forces act for a very short interval of time. We call such events as collision. I'll give you 2 minutes to note it down. What we see in a collision is that impulsive forces act on a body. Now, uh, whenever we hear about collision, we always think or understand that for a collision, the body must come in contact. Remember, collision is possible even without bodies coming in contact. So remember all these points. These points may come as questions in your exam. So for a collision to happen, the contact, the bodies may be in contact, the bodies may not be in contact. So remember this. Now, whenever we talk about collision, the time of collision is very small. The impact takes place for a very small time. So you must remember this whenever we are talking about the collision. Okay. So I'll give you 2 minutes to note this down. So now we have seen the important points about collision. Now there are a certain terms that we'll have to understand about this collision. Now this is just for your academic purpose. You may not get any question on this. The first term that you must understand is the line of impact. Line of impact. Now what is this line of impact? This line of impact, or in short if I call it LOI, this is the line, or this is the line or the direction. This is the line or the direction along which, this is the line or direction along which the impulsive forces act. This is the line or direction along which the impulsive forces act during an impact or collision. During an impact or collision. This is also the line. This is also the line along which momentum. You understand the meaning of P? You understand the meaning of P? Momentum of particles only change along this line, along with the momentum of particles change. So whenever someone tells you about the line of impact, it is the line along which forces act. Since it is the line along which forces act, this is the line along which the momentum of the particle is changed. It is normally, it is perpendicular or common normal to the two bodies. This line of impact is perpendicular to the two bodies, or you can say it is the common normal between the two bodies. And I can give you some examples of this. Where is the line of impact? And you will see that this line of impact is the common normal. Normal, you understand the meaning of normal? Normal is perpendicular, yes or no, bacha? So common normal is normally your line of impact. As you can see in this diagram, the diagram is coming on to you. You can see two bodies colliding here, and you can see this pink line. This pink line is the common normal, and this is the line of impact. So the line of impact is always along the common normal. I'll give you 2 minutes to note this down, and I'll show you one or two more diagrams of the line of impact. Okay, as I told you, I will give you a few examples of the line of impact. I had shown you one example. Now this is another example where the bodies are having an impact. They are moving in different directions, but you can see the line of impact is always along the common normal. Do we see this? The line of impact is always along the common normal. And I will show you one more diagram with this diagram, so that you can just draw this and understand that the line of impact is always along the common normal. The line of impact is always along the common normal. This is what you have to understand. And these are the two examples. You can see in this example, balls are moving in different directions, but you can see the line of impact is along the common normal. Here, a ball is falling on a wedge. The line of impact is along the common normal. Do we see this, everyone? Yes or no? Okay, I'll give you 2 minutes. A line of impact, and you must remember the important points about the line of impact. Now, apart from line of impact, there will be one more thing that will be coming in the discussion, and that is known as coefficient of restitution. So I will just go through this coefficient of restitution. Coefficient of restitution It is a number and it is denoted by E, coefficient of restitution. Now, what is this coefficient of restitution? What is this coefficient of restitution? Now, the formula for this coefficient of restitution is like this, and you must remember the formula, and then I will tell you some examples of this. The value of E is velocity of separation, velocity of separation, and this velocity of separation is along the line of impact divided by the velocity of approach. Velocity of separation divided by velocity of impact along the line of impact. Now you might get confused. What is this velocity of separation, and what is this velocity of approach? Don't worry, I'm going to give you a diagram, and that will make things very clear. What is this coefficient of restitution? Now see, this is a diagram that I have taken. Two bodies colliding. Now the body number 2 is moving ahead and body number 1 is impacting it from the behind. Here the initial velocity u1 is greater than u2. Right? Then only this back body will be able to impact this. Do we understand this? Yes or no? So now after collision, what happens, beta? The velocity v2, the final velocity v2 of the body which is ahead, because of the collision, this body is moving slowly, but this body is moving fast. So after collision, what happens? This body moves fast and this body moves slow. Yes or no? Do we understand this? So v2 is greater than v1. So velocity of separation, my dear friends, is the velocity which they are separating, and you can see, my dear friends, that velocity of separation will be v2 minus v1. Do we understand this? And similarly, your velocity of approach will be u1 minus u2. Do we understand this? So this is the formula for coefficient of restitution, my dear friends. Velocity of separation divided by velocity of approach. So just remember this formula. Draw this diagram. I'll give you 2 minutes to do this. So we have seen what do you mean by the coefficient of restitution. Now we go into the next heading, which is classification of collision. How are collision classified? Classification of collision. How are collision classified? How are collision classified? Well, number A, on the basis of line of impact. On the basis of line of impact, I can have two types of collision. The first type of collision is known as head-on. Head-on collision, or 1D collision, collision in one dimension. Head-on collision or 1D collision is the first type of collision. So what happens in this head-on collision or 1D collision? Velocities of both bodies, velocities of both bodies before collision is same. If the velocities of both the bodies before collision is not same. Oh, sorry, is along the same line. Is along the same line. The collision is called as head-on collision or collision in one dimension. Head-on collision or collision in one dimension. So we say the body are colliding head-on. So you can see this example. The previous example also was the same example. Here before collision, you can see body number 1 and body number 2. They are moving along the same line. Do we see this? So this is an example of, my dear friends, head-on collision. Both the bodies are moving along the same line before the collision. Do we understand this, bacha? This is an example of your head-on or collision in one dimension. Before collision, both the bodies are moving in the same direction, in the same line. Now, they were also moving in the same direction, but there could be a case like this also, my dear friends. In case number 2, as you can see, they are not moving in the same direction, they are moving in the opposite direction, but they are moving along the same line. So this is also an example of head-on collision or collision in one dimension. We understand this, everyone? Can I have raised hands? So this collision is known as head-on collision or 1D collision. Now remember this velocities are along the line of impact. Velocities are along the line of impact. So you can see both the velocities are along the line of impact. Such collision is known as a 1D collision or a head-on collision. Has everyone noted this down? Yes or no? Okay, that takes us to the second type of collision in this, and that is known as oblique, or you can call it a two-dimensional collision. Now, what is this two-dimensional collision or a oblique collision? If any one of the body is not moving along the line of impact, then the collision is known as a 2D collision or an oblique collision. So even if one body is not moving along the line of impact, the collision becomes oblique. If both the bodies are not moving along the line of impact, then also the collision is oblique. Do we understand this? So one or both the bodies not moving along the line of impact, bacho, the collision becomes oblique. This in this example, as you can see, the first example that I am showing you, there is only one body which is moving, that is the ball, but that ball is not moving along the line of impact, and therefore this collision is an example of oblique collision. Do you understand this, bacha? Only one body is moving, but it is not moving along the line of impact, and therefore the collision is collision in two dimension or an oblique collision. In the second example that I'm going to show you, and these are examples that we have already seen previously, I am again showing it to you. These are the same example that we had drawn for the line of impact. You can draw them in the same diagram as well. In the second case, you can see there are two bodies which are colliding and both are moving in different directions. one body is moving like this and the other body is moving like this. Both are moving in different direction. This is also an example of oblique collision or collision in two dimensions. I hope you are able to understand this small difference. But if you are able to understand this, you are going to get a lot of questions based on this. Okay, we understand this, everyone? Oblique collision and head-on collision. Okay, we got this. Okay, so this was the first classification of collision on the basis of line of impact. The second classification is on the basis of energy. Is on the basis of energy. What happens with energy? I hope everyone is writing it down. Yes or no? Okay. Now, in this, we have three types of collision. The first collision is known as perfectly elastic. Perfectly elastic, or sometimes people also call it simply elastic collision. They don't use the word perfectly elastic, they call it elastic collision. Elastic collision actually means perfectly elastic collision. So you must remember this. Elastic collision actually means perfectly elastic collision. Now, I will give all these points of this perfectly elastic collision point wise, that will help you in understanding them. So, what happens in a perfectly elastic collision? The word elastic means they will regain their size and shape completely. So, that is the first point you must remember. The particles regain their original size and shape completely after collision. During collision, there are some deformations in the body, and therefore, if a collision is perfectly elastic, the bodies will regain their shape completely. Do we understand this? So there will be no loss of mechanical energy. There will be no loss of mechanical energy. Therefore, kinetic energy of the bodies, kinetic energy of the system, kinetic energy of the system remains conserved. Kinetic energy of the system remains conserved. What do you mean by kinetic energy of the system remains conserved? Final kinetic energy becomes equal to initial kinetic energy. Final kinetic energy becomes equal to initial kinetic energy. Now, what do you mean by initial kinetic energy and what do you mean by final kinetic energy? You must know this. If we take the case of two bodies colliding, the final kinetic energy will be half m1 v1 square plus half m2 v2 square. You know the meaning of v1 and v2? You know the meaning of v1 and v2? What is v1 and v2? What is v1 and v2? V1 and V2 are the final velocities of the two bodies. That will be equal to half m1 u1 square plus half m2 u2 square. What is U1 and U2? U1 and U2 are the initial velocities of the two particles. So the kinetic energy remains conserved. Then momentum of the system remains conserved. So remember, momentum of the system remains conserved. Momentum of the system remains conserved. Momentum of the system remains constant or remains conserved. That means initial momentum would be equal to final momentum vectorly. So final momentum will be equal to initial momentum vectorly, or you can write m1 v1 vector plus m2 v2 vector will be equal to m1 u1 vector plus m2 u2 vector. Are you able to understand what I'm writing here? All these points written systematically one after the other. Okay, I hope you are noting it down. We move on to the next point. The coefficient of restitution is 1. Remember, the value of coefficient of restitution is 1. Now, that means 1 will be equal to V2 minus V1 divided by U1 minus U2, or you can say V2 minus V1 will be equal to U1 minus U2. V2 minus V1 will be equal to U1 minus U2, or you can say velocity of separation will be equal to velocity of approach. Velocity of separation would be equal to the velocity of approach. There is one more point, and I hope I will tell you that point as well. Everyone is noting it down? Well done. The last point that I have to give you is impulse of deformation. Impulse of deformation will be same as impulse of reformation. Now you will ask me, sir, what is this impulse of deformation and impulse of reformation? So beta, please understand that whenever collision is happening, the two bodies are coming in contact. When the two bodies are coming in contact and you observe this collision by a very fast or a very good slow motion camera, and you might have seen the collision of a ball with a bat with a slow motion camera, you will see that this ball gets deformed. Yes or no? The ball gets deformed. In fact, whenever two bodies are colliding during collision, they first get deformed and then they try to reform. Deform, reform, deform, reform. Deform means their shape changes. Reform means they try to come back to their original shape. Deform, reform, deform, reform. Do we understand this? Now, they are going to get deformed. If they completely come back to their original shape, original size, then the collision is known as perfectly elastic collision. Do we understand this? They are going to get deformed, but then if they come back to their original shape and size, that is what we call perfectly elastic collision. Do we understand this? Therefore, the impulse is nothing but the force which is trying to deform it will be the impulsive force which is trying to deform it, and that is why we call impulse of deformation is equal to the impulse of reformation. So whatever they deform, the same they reform. Whatever their shape changes, they come back to their original shape. Such type of collision is known as a perfectly elastic collision. And I've given all the points of this perfectly elastic collision, and I'm giving you time till tomorrow, not till tomorrow, till Monday, to go through all these points, because most of the question, 98 or 99% of the question that you're going to get in this particular topic will be from perfectly elastic collision. So remember all these points very, 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 very carefully, because all these points are questions in themselves. If you can remember them, you can just mark those questions and go ahead. So I'll wind up this class here. Two more types of collisions are left. We will be discussing their points in the next class. If you remember the points of this collision, the points of other collision become very simple, because everything will be there. You just have to understand what things will change and what things will not change. That is the only thing that you have to understand. So remember all these 6, 7, 8 points, whatever we have written. Please remember them. And if you can remember them, well, then you will be able to understand all the collisions thoroughly. Take care. God bless all of you. If there's anything that you have not understood better, please feel free to ask me. Bye bye.
Bye, sir.